of this precursor. Or, for example, this is an activity that I did during my PhD, is to use the nanoprinting in the field of printed electronics by using a polymer that is semiconductor polymer. You can obtain, simply by using nanoprinting, the nanostructuring of this polymer to improve the electronic properties of this material. For example, this is the example of the patterning of pillow, that is this polymer that is used for organic solar cells or organic electronics. We use for polymeric solar cells, but you can imprint or replicate the structure also using small molecules or other semiconducting polymer. The advantages of nanoprinting is that you can obtain 3D structures that is it's not easy to achieve with other technology. For example, this is the work that we did for European Space Agency, where they have to produce a kind of dry adhesive that we employ by in the space for the when the people actually from the shuttle to walk on the shuttle outside, and we produce this nanometric structuring of the polymer, and we obtain really good results on the adhesive property of this dry. Again, this is, we produce the mold by having these microstructures with UV lithography. Then we produce this nanostructure by EBL, and then replicate by nanoprinting. This is just to show that when you are considering to, when you are fabricating a sample, you must combine many different techniques. You are not just using a single technique, but generally it's better to, or is necessary to combine many techniques to achieve the final result. And you must know how to combine. So there are, this is just for patterning, but I will show you that after the patterning there are many steps that are the to transfer the pattern that you are producing on your substrate. Because generally, when you have the resin that is patterned, it's not the end of the process. Because you don't want to have the resin that is patterned, but you want to have the sample that has the pattern that you need. And you must combine not just the patterning, but also the post-processing, such as the etching, wet etching, dry etching, or the deposition of particular materials. But you must think also, in this case, what is that you needed to obtain the final sample. Simply, just to describe what we are doing, wet etching. Etching is when you are removing selectively the material on the exposed region of your sample by reproducing the pattern that you have on your resin on the substrate. So we can distinguish in wet etching when you are doing the process in a solution. In particular, we can distinguish between isotropic and anisotropic etching, and dry etching when we are exploiting the use of a plasma to selectively remove the exposed part of your sample to replicate the structure here. Or when you are techniques of additive techniques, such as deposition of particular materials that can be exploited for etching, or you do the etching and then deposition. So you can combine in infinite way the techniques that are available in order to obtain the sample. This is an example of dry etching. This is the deep reactive ion etching. The system is pretty simple. You have the substrate, generally that is silicon, derived from the strength industry, and you have the suitable mask, metallic mask, generally. By using suitable gas for the substrate that you are using, you can selectively remove the silicon on the exposed area. Then you passivate the starter that you need, then you etch again, and you are replicating this cycle many times, obtaining these deep structures here. These are some examples of structures that we produced with this technology of deep reactive ion etching. What is the use of these structures? So we use this high-resolution pillar to make biological sensors. This is just a selection of the publication that we did for the fast detection of biomolecules in liquids. Simply, we use these pillars to have a super hydrophobic surface. So that I must explain what is a super hydrophobic surface. So when you have a really high resolution structure here and you are functionalizing the surface of this structure, the liquids, particularly the water, can wet inside this structure, but is somehow suspended at top of these pillars, and you are creating kind of water spacing in between the liquid and the substance. By moving this or oscillating these pillars, you can appreciate what is deposited on top of these pillars by measuring simply the resonation frequency of resonation